Thanks everybody for turning up for this. Hopefully one of the reasons why you're here is that you caught my thinly veiled dig here at Kubernetes and how we think there's an opportunity now to think about how to design management of containers at the edge that actually delights developers, makes it easy to use, and provides some great abstractions. Avassa is a software company out of Sweden. We are heavily focused on building orchestration and automation systems that delights, again, developers with a heavy focus on applications. We're very happy to name the Gartner Cool Vendor 2022 based off of, I hope, our ideas and the directions that we're taking to really be able to lower the barrier of entry for people that are used to the comfort and the experience of the hyperscaler clouds, but now at the edge. So real brief, and this is usually one of these frequently asked questions that I've lined up to kind of pad my presentations on. What is the difference between the cloud paradigm that we are used to and the edge paradigm, and what kind of interesting challenges do they bring for the application teams? So if you guys remember, and I can see that all of you do remember, the cloud assumptions was that location, physical location for where your applications are hosted is reasonably unimportant. As long as it's on a continental scale, you're usually fine. Data centers are massive. There's a lot of computers. Actually, from an application point of view, there's infinite amounts of compute available. And it actually brought very interesting new processes and tooling as we went from local data centers into the cloud paradigm. And of course, the reason why we're here, at least the edge part, is that things have changed subtly, but importantly. For the edge world, and I think most of my peers here will agree, location actually matters. There's a point to why certain locations are where they are. Geographically, usually has to do with being close to something or to someone. Each of these locations usually carry way fewer computers than a traditional data center, but in very many locations. So scale down resources, but in tens, hundreds, or thousands of locations. And resource constraints, and this actually comes as a surprise for people having grown up in the cloud, is a thing. You actually have to think a little bit about how you design, how you lifecycle, how you deploy applications when you have hard edges, so to speak, to your resources. And my kind of one observation is that I've never seen anything scare application people more than getting to know the Linux out of memory killer, that it's called, that will actually summarily just kill off processes if you run out of resources. So the question here that I'm going to try to make it come alive for you is that can we use what we have to approach this hassle? And what I find to be very useful is to tease apart the roles and responsibilities here. And it's important enough that we've actually given these idealized personas names. So let me present to you, we'll actually start on the right side, Patrick McEngine. He's an IT and platform engineer. He works on infrastructure. He loves wiring. He loves selecting hardware. He has particular favorites in the operating system layer, and he cares deeply for building robust infrastructure. Some Patricks know that what they are at heart are enabler for application teams. That's why they are around. They are building infrastructure such that our left person here can do their job. And our left person, we call her Applifer Developes. She's an application developer. She cares deeply about designing, architecting, and coding, at times, applications. Very passionate about the application layer, but she's at times surprisingly disinterested in the infrastructure. I've had many Applifers tell me, I just want to run my applications. Spare me the details, just allow me to run my applications. The cool thing about her is that she drives the value stream. He's usually one-to-one connected with actually creating value for the company, depending on what kind of company we're talking about here. And the number one setup that we walk into as a vendor in this space, talking to enterprises, large and small, about what their current issues are, is that it's been a very Patrick-heavy world. Patrick has gone along and built edge infrastructure on a hodgepodge of his favorite tools, usually a lot of open source, usually a lot of things he brought from the public and private clouds. So he's built a slew of mini data centers with many, many moving parts. And what he hasn't built is that he hasn't built an infrastructure for Applifer. So invariably, they end up with one or more Applifers having a number of applications that she needs to deploy, but she has to work through a manual handover and literally give the software to Patrick that will then not only manage the infrastructure components he's built, but also try and deploy the applications at the pace that Applifer is able to develop, test, and make them ready for deployment. Because, of course, Applifer is a thoroughly automated person. She has a nice CI/CD pipeline with a lot of automated tools. So not only does she have a set of applications, she also has a queue of versions of that application just waiting to be deployed. And as you can see, their manual handover here becomes a pretty bad bottleneck. Patrick is overwhelmed and Applifer is underwhelmed, to put it mildly. And the pace of innovation, the pace of deployment, and the pace of delivering features is horribly slow. Now, as a particularly interested person in computer science, what we usually do is that we turn to abstractions. And we realize that the abstractions that that kind of setup provides is wrong for this. And what you then do is you dive a little deeper and you think about what are abstractions and where do they come from. So let me just go on a small tangent here and tell you about where abstractions in computer science came from. Her name is Barbara Liskov. She literally invented the term abstractions in computer science. And the way she describes what abstractions are is one of these descriptions that are almost self-evident, sounds ludicrous, but was absolutely breathtakingly new at the time. So what she says is permit the expression of relevant details and the suppression of irrelevant details. And if you take this and map it back to your experience with IT, you can see that Barbara should have a way bigger impact on life than what she has had this far. So how do we go about applying a Barbara Liskov-like approach to the conundrum that we talked about? Well, the first thing we do is we think about the world from Applifer's perspective. She cares about two things. She cares about the definition of an application, because that's what she does. And she cares also about where her application should run, which is usually part of the value stream. What are the criteria for her application to run successfully or valuably? And put those two together, and that should actually lead to a running set of applications that she can deploy and in some forward-looking environments actually observe. Many enterprises that we talk to, they've actually handed over the monitoring of live applications, not to the IT team, but to the actual application team. You deploy it, you monitor it, you operate it. What Patrick can do is that he can sit back and relax, install sites, monitor sites, and make sure that it's a secure infrastructure. So now we're getting to what I believe to be the correct, or at least significantly better abstractions. Give specification of application and deployment to Applifer, take Patrick out of the way, allow him to focus fully on managing the infrastructure. There's this emerging term in our beautiful industry called platform engineering. It's rapidly rising, and I'm sure it's going to go away until we're back here next year. But one of the things that I take out of that conversation is the term golden path. What should a golden path look like based on correct, or at least significantly improved abstractions for edge environments? Again, we believe that a developer request, someone like Applifer, should be able to formally express what it is that she's running. And because we're techies here, that would entail many things like which containers, what is the configuration for those containers, are there sensitive data that should be passed along with them, like certificates, like secret passwords and stuff like that, and where, and make it formal, what region, what are the requirements from the hardware? Does this require a camera or a GPU? And allow that expressivity to be owned and life-cycled by the application team, out of sight, out of mind from the platform team. She does that, she passes it into an application-centric edge platform, like the one that we happen to have, over in our booth. I'll be happy to demo that for you. And that then gets passed to the platform owned by Platric. Platric's platform knows how to read the application specification, match site and host definitions, and deploy the application to the sites without him actually manually intervening. And the platform itself then takes care of the stitching, meaning, is there a canary stage? Do we have to try this application out first under some circumstances? How do we actually place this on a host level? How do we match, for example, the requirement for a camera on the right host? How do we secure the networking? How do we distribute the secrets? How do we spin up and make sure that we get health and liveness probes running? And that's then done. So again, please note that the golden path is driven by the developer request, usually out of a CI/CD or GitOps style pipeline. It does not involve manual intervention by the IT and platform team, but results in a living, breathing, hopefully healthy set of applications running across edge environments. Of course, we want to show this to the event. So in our booth, we've brought one of our customers' equipment. This particular customer actually has a LiDAR-based monitoring system, so they deploy LiDARs in mining environments to make sure that people don't walk into the wrong parts of the mine, to make sure that people don't generally move in a way that's not permitted in this particular mine. And the interesting thing for them was, of course, at the heart of what they do is that they have a piece of software that knows how to take LiDAR data and turn that into managed or actionable data and actually trigger alarms or other types of transactional results. What they're not interested in is building a platform based on someone like a Platric. They are the proverbial applifers here. They care only for their applications attached to the right type of radar. So using the kind of abstractions that we think are the right ones here, and without using, of course, Kubernetes, they could go from a standalone product to delivering this as a service with massive reduced manual work. Again, 2 manifests, what's the application and where to run it. Deep isolation for application security. They have training sets that needs to be protected at the edge. And of course, remote and centralized lifecycle management of the versions of both the machine learning models and the applications themselves. And over time, of course, they need to be able to monitor both the connectivity to each site, but also the health of the actual software doing this very, very important work inside of the mines. So by putting this all together with the right abstractions, they're now on their path of being a leading provider of GDPR-compliant deviation and incident detection solutions based on LiDAR, predominantly in mining environments here. So since this is a short demo, I'm going to leave you with this. Let's all try to make Barbara happy and focus on the expression of relevant details and think about for who, and focus on Applifer to do that. And please, let's leave out irrelevant details and spare Applifer from the detailed worldview of a Platric, and Barbara will be good with this. That's almost perfect timing for questions.
We definitely have time for questions. And in fact, I wanted to say I really appreciated the persona-based kind of methodology that you think about.
I love both of them. We love our Platrics and the Applifers. Yes.
Yeah, no, so I have a question then. I'm gonna come up. So you mentioned like the mining application.
Yes.
Right, so that's an interesting one from an edge perspective because in some cases those are environments that are disconnected.
Yes.
Sometimes, so tell me about what you're finding in terms of like connected versus disconnected environments.
Yes. So the interesting thing, and this actually comes back to the operational side, almost the monitoring side. Good point. Many of our types of users, the fact that you lose connectivity to a site can be very undramatic, even planned. So maybe a small detail, but in our UI, for example, the fact that you lose connectivity to a site doesn't actually provoke a red dot, it provokes a gray dot. So you actually have to think about what operational monitoring with many locations mean, because again, if you're in the hundreds or even the thousands, you know you're going to have a handful or two of sites that are going to be out of pocket at any time. Some of them planned, some of them unplanned. And you should have designed your applications to survive that kind of thing. And you should have a platform that can also not keel over and die if you predictably lose connectivity to 1 or 2 sites over time.
Yeah, the other question I have is, it's definitely a positive, I believe, for developers to have that abstraction layer. But there's always the question of, by doing an abstraction layer, am I missing something, right? Am I losing out by not having, so what is your opinion on that?
That is the art of software engineering. And I'm saying with a fully straight face, that is the art of software engineering. How do we suppress irrelevant details and how do we surface relevant details? And it comes down to understanding the worldview of the user. In our case, we focus heavily on Applifer. What is a useful set of abstractions for that person to do her job in this case, right? And of course, the details are all in the demo, and it's ever evolving because it's a little bit of a new field. But in my mind as a CTO, that's actually where the cool stuff happens. How do we find stable, maybe even common, decent and useful abstractions that are easy to use for application teams?
And so maybe the final question is, so where is this going? Like, where do you feel like so where people are today in terms of their understanding and ability to deliver these types of applications to what it might look like maybe 2 years from now?
Yeah, I think most of our users now are fully tuned to the art of deploying applications. What's still down the line is what some people call day 2, day 3. As I mentioned, what does it mean to monitor an application if it has 2,000 replicas, across a set of edges instead of 2 replicas that might be the case in centralized environments? And how do we wrap our operational culture around that? So I think as an industry, we're now fine with kind of day 1, how do we design and deploy things? It's the day 2 and day 3 things that are going to pan out, of course, over the next coming years here. So actually, that kind of opinion actually shifts the focus a little bit to Platric and the monitoring team, for them to provide that nice green, status on whatever's going on. So I think shifting from day 0, day 1 to day 2, day 3 is what we need to track here the coming years.
Excellent. I think it brings us back to that concept earlier about life cycle, right? Like now as Edge becomes more mature, you have to really think about it in terms of how you build it, how you manage it, and then how you over time continue to evolve it, right? It's all of those things.
Absolutely. And like you said, I think in previous sessions, it's also what's the cost of bringing up a new site, of decommissioning a site. There's a question. That's lovely.
Oh, great. So, excellent.
A question came into my mind. Who is your customer? Because I can see this being used by ISVs. I can see this being provided by a hyperscaler or a telco to their customers, being ISVs. So who's your customer?
Yeah, so we have examples of all 3 that you mentioned. Let me tell you about where it's moving the fastest. ISVs. Because for them, it's a barrier of value extraction. They already have the application. The only thing between them and screaming success is the ability to deliver. After that comes, let's call it the enterprises or the site owners. You think large retail chains that have a strategic reason to make platforms out of their retail outlets.
Okay.
But some of them are struggling to find that first super valuable application. But we cater to both, but if you were to look for where the action is going on right now, I think ISVs is a good bet to look at.
But they have to be relatively sizable to allow for that.
Actually, this company, the FlashEye example, is a very small company. I mean, there are 25 people or something. And they can now deliver to hundreds of locations, right? Yeah. Thank you for that question. Okay. Yeah. One more.
Just a last one.
Okay.
Yeah. This is more
That's
of
what I said. Just one question, then everything just...
more of an architecture question. You
Sure.
talked about complexity
Yes.
In the tagline initially.
Yes.
Why is Kubernetes an overkill for edge applications?
Because it has the wrong abstractions.
Can you elaborate a little more?
Yes, sure. Real brief, otherwise someone's going to stab me here. If you look at this, almost all the abstractions provided by Kubernetes is towards our buddy down to the left. Almost no abstractions provided by Kubernetes is to our developer. If you look at the APIs, literally, it has very little to do with just running an application. It has a lot to do with the infrastructure. And if you then start to add the components that you need to Kubernetes, somewhere between 10 to 20 of them to make it a platform, you're back to here, where 80% of his time is about upgrading the components, the constituent components of the Kubernetes platform. And there's no tooling for our application team. Yeah. Thank you.